Let's see today's question. So you are given an array and an integer array, integer max operations, and the array is like the bags. Okay. Let's take this array. So there are like four bags, and in each bags there are balls. Okay. So the value in the array specifies the number of balls in that particular bag. So in the first bag there are two balls, in the second there are four, and likewise. And you're also given an integer max operations. So what you have to do is like you can perform at most, like at most maximum number of times max operations. And what is that operation? You pick any bag and divide that bag into two bags. Okay. And like the number of balls should can be equal, can't be equal, cannot be equal. So like if you take an like example, a bag which contains five balls, you can divide it as 1 and 4 and also 2 and 3. So you have to divide it into two. Okay. But yeah, the number of balls present in a bag should be greater than zero. It should be positive. Okay. And you have to do this operation at most max number of max operation times. Yeah. And what you have to return is the maximum number of balls in a bag, maximum number of balls in a bag, and you want to minimize the your penalty. What does this mean? Like example, you if you take this array, okay, and you can you can do that operation at most four number of times. So if suppose the max operation would be zero here. Okay. So what would be the answer? The answer would be 8, because 8 is the bag which is containing maximum number of balls. Okay. So you will return that. But after doing this like that operation four times, you have to return what can be the minimum. Okay, well, you have to minimize it, like minimum number of balls that is maximum in all of the bags, from among the all of the bags. So like here in this example, what we can do, like we can we are like it's very intuitive that you are getting like the largest bag is 8 wala bag. So what you will do, you will divide it, because you want to reduce that the largest thing. So you will divide it and you will get 4, and for two bags you will get of two bags. Okay. You will divide it equally, and then next what you will do, next you will see which is now the highest, which is the bag which is cutting the highest number of balls. So you will see 4. So you will divide it again. So you will get now 2 2 2 and 2, and then you will again see the third thing. So likewise you will divide it, and at the last when you uh, applied all the four operations, you will get this array, and then the answer would be 2, because 2 is the maximum number of balls present in any bag. Okay. Yeah. So but if you like what the approach for solving this question would be using binary search. Why is it binary search? Because you can see here that the time, like the nums I can be of like 10 to 9, and operations also can be 10 to 9. So you can't run every operation. Okay. So you have to come up with approach something like n log n. Okay. And n should be like this, and this should be in log n. So what I have thought of this question was, it was not intuitive, but yes, after some time I came to like what we can do is, we will like what can be the answer of this question. Okay. Like if we suppose take this, what can be the answer? The and let's not take consider this right now. If we consider only this, then what can be the answer from this array? Okay. So the answer could be at max 8, or minimum like 1. Okay. Means the answer can range from the 1 to the maximum element of the array. Because if there are zero operations, then therefore we will return 8, like the maximum number. And if there are like some number of operations and we can reduce all the elements to 1, then the answer would be 1. So yes, so we have to like apply binary search on the range 1 to max. Okay. So I will write it here. Binary search on 1 to max. Okay. Max element. Okay. So like how will we apply? Okay, let's take an example. uh, let's suppose your range is from 1 to 10. Okay. and now obviously the mid of this will be, mid will be 5 if we like 1 plus 10 divided by 2, 5. So now we will check that can 5 would be the answer for this question. Okay, so we will write some function. Okay, let's write actually public. This will return a boolean variable, true or false, is answer. It will take the array int m, that is max operation, and int x. So this is the x is the, like, we are assuming that x is the answer. So let's assume that 5 is the answer, and we put that 5 into this function, and that function will return that 5 can be the answer or not. So likewise, if 5 would be the answer, what we will do, we want to minimize that, so we will make calls for the elements 1 to 5. Okay, so we will make calls for elements 1 to 5, but if 5 is not the answer, okay, so the elements less than 5 cannot be also answer. It can't be also answer. Why? Because if we can't make like if we can't even do this, we can, if we can't make the answer as 5, we can't also make like answer less than it. Okay, so therefore the answer will, if not like if 5 is not the answer, then the answer would be greater than 5. So uh, I will write it, if answer is 5, minimize, check for the lower elements, less than elements which are less than 5. And if 5 is not answer, obviously we can't check the elements for which are less than 5. For the elements which are less than 5, we have to check from 5, not 5, 6 to 10, in the range of 6 to 10. So this is binary search now, so that's why we will apply. What would be the logic of this function? I will write that also. So let's start first writing. So first of all, I will sort the array. Okay, and what will be the starting index? Starting index will be 1, like at minimum of what could be the answer, 1 can be the answer, and at max what could be answer. So it could be like nums of nums dot len. So maximum element in the array, that could be the answer. Okay, I will just take it long. Okay, yeah, so binary search, I will apply simple binary search. Start is less than equal to n. Okay, so int mid is equal to uh, s plus e divided by 2. Now if is answer is answer, I will call is answer function for checking that can mix mid be the answer. So nums max operations and mid. If mid is the answer, okay, mid is the answer, I will call in the like elements for, I will call for the elements which are less than mid. So I have to go in left. So what I will do, I will just do end is equal to mid minus 1, and also I will keep an answer variable, and let's suppose at starting we are considering answer as max, and I will update it here because we got an answer now. So I will update it here as mid. Okay, and I will look for the, like, can I minimize it in the left array. Yes, and if it is returning false, that mid is not the answer, you have to look in the uh, elements, we have to look for the elements which are greater than mid. So start would be mid plus 1. Okay, and yes, and at last you will return the answer. Okay, now what would the function like, what would the what would be the code for this answer. So what we have to check, is can we use max operations, and can we like we can we use the operations max operation times and make the largest element in the array as x. So if let's take this example. I have taken 5. Okay, 5, like can we make the 5 as the answer? So obviously the elements which are less than 5, we have to not make it we have to not reduce it now, but less than equal to 5. But the elements which are greater than 5, like 8, we have to see, can I reduce this uh, to less than 5 or equal to 5? And the constraint is I can use only max operation times that operation. Okay, so what I will do, I will just traverse in the array. Now if uh, that nums of I is less than or equal to x, okay, if it is less than equal to x, I will continue. I have to do nothing because and the array is sorted. Okay, so I have to do nothing as they are, that is already less than 6, so I have to not less than 5, less than x, so I have to not reduce it. Okay, I'm writing this to consider that I am getting true as the answer, but I will change it in the for loop. Okay, now the element which is greater than x, okay, what I can do for it. So if I have to make it less than x, okay, I have to know that how much times can I divide it. Okay, so I will required how much I have to know. So required will be nums of I divided by how much x. So now I will get to know that how much times I have to divide it. Okay, so let's suppose if I have to divide into two parts. Okay, so how much operation I will need? I will need only one operation. Okay, if I have to divide it into for 5 parts, I will need only four operations. Okay, so yes, from here, uh, but there is one more thing, that if it is getting totally divided, that is nums of I modulo x, if this is not equal to 0. Okay, if it is getting totally divided, there is no problem, but if it is not getting totally divided, we have to increment this as you can see, like if 8 is there and if you divide it by 3, you will get the the answer as 2. But uh, but actually you are dividing it into three parts now, 3 3 and 2. That's why you have to plus it. And yeah, and also, as if you required is like 5, so you're dividing it into 5 parts, but you require only require -1 operations, four operations. So you will check if uh, require -1, if max operation is less than require -1, what I'll do, I will just make the flag as false, because I'm not getting the answer, because I can't do the current one, uh, less than equal to x, and I will break from the loop. Okay, and if I can do it, I have enough operations, what I will do, I will just do it and reduce it by require -1, and at last I will return the flag. Okay, yeah, so let's run this. Okay, so it should not be max, it should be e. This should be converted into int. Yeah, it's working, let's submit it. Yes, it's working. Okay, thank you for watching.